Welcome to our lecture about internet security, weaknesses and targets. Today we want to speak about attack, intrusion detection, how we can see whether there is a system detected. There are several methods available, and we want to see. In our lecture, it fits that after having discussed the various weaknesses of the operating systems, of the communication software, of the application level, human factors. Now we want to see how we can control, how we can detect whether anyone is attacking our website, our system. A few words about introduction, why one needs such detecting system. And the reason is that the complexity of IT systems, the various weaknesses we have already discussed, newly discovered attack methods, this all is a reason that there is no absolute security. Absolute security for computers, absolute security for networks, and particularly if the systems are connected to the internet, then there is a danger, the real danger, to be attacked from the internet. There are different reasons. Rapid development of systems, so new technologies come into place and people do not fully understand or do not understand side effects or do not see weaknesses in the very phase. There is a giant complexity of these interconnected systems. Not even operating system is a complex system. The operating system with the applications is even more complex. And if you combine all the system over the internet, if you interconnect the systems, then there is a huge complexity of hardware, of software. And this also helps that failures start to become potentially important. We have discussed this during our lectures in many points. Even if a system provides good methods, good techniques, the human failure that administrators do not correctly control configurations, that they do not correctly manage the system, that in an organization IT systems are not correctly organized. Also, this provides the possibility that attackers can be successfully attack a system. And for that reason, one needs systems which are able to detect whether the system is currently under attack. So it's absolutely necessary to always keep watching an IT system. The goal is to predict, is there an attack, to detect, is there an attack, and perhaps also to draw a conclusion. For example, to cut a process, to cut an interconnection, to switch off the whole system. So ideally, this detection should be in real time, that one sees now in this moment my system is attacked, my network is attacked, and then the system helps administrators or perhaps by some automatic procedures to protect the system against this attack. We will see that's difficult. That's difficult due to many reasons, but even if it's not possible to detect in real time that there is an attack running, that there is an intruder, it is at least important to see that there was an attack, that an intrusion was successful, for example, last day, so that one can analyze how the intruder break in, what was a mistake, what was a weak point the attacker could misuse to prevent for the future. So security relevant actions. There are simple ones, for example, an individual access to a file. There are more complex ones, the change of a database, of user management. All these actions, in fact, future work of a system. For that reason, And particularly if people want to account the work or audit a system, this requires that a central report need to be maintained which lists all events that could have, in fact, an impact on security of the system. So a central report is required to listen to all events and behaviors of the involved users. This is done by means of so-called audit logs. An audit log must record every security-relevant event. We will later see it's not so easy to decide whether it's security-relevant or not. Almost all actions have some aspect for security relevance. But of course, it's much too much to listen all. The audit log should gather the related information from different resources. For example, should investigate log files from the operating system, the log files from the applications, scanning reports, the intrusion detection systems alerts, antivirus reports, firewall reports, warnings, monitor logs, and others. All this could give information, all these logs could give information whether system is working in the correct modus or whether there is a system under attack. What is important, what is very important, is that the audit log have to be protected from any external access. If you do the work and record all this security relevant data, and if an attacker can get access to the audit log, then he can hide its action by deleting relevant information or suppressing information. So the audit log need to be protected from any external access. This is a point the attackers are very much interested to see and get access and perhaps to delete this audit events. If we have a closer look to these audit logs, then the major problem is the volume and the analysis of that many data that need to be collected because they have an impact on the secure behavior of a system. Due to the enormous volume, this audit data need to be reduced. Need to be reduced or need to be compressed, and this is the so-called audit log reduction. Audit log reduction, I mentioned what kind of data need to be collected because they can give hints about the behavior, this behavior with respect to security of a system. But there are so many data, and of course this data need to be collected and processed by the same machine that's used to solve the problem. So it needs a lot of computational power and computational resources to collect this data. So one has to think carefully what kind of data are really needed and what kind of data need to be logged to be able to find out irregular behavior of a system. So the aggregation, so-called aggregation or the correlation, whether single data are useless, but in combination with each other, these correlated data give a hint that there is an attack. These are often applied for fast analysis as well as other purposes. So there are a lot of techniques available, very interesting computational techniques for aggregation and correlation of the system. This is a real problem due to the mass of data that need to be analyzed, that high-performance computing techniques are needed to process the security-relevant data. So I will, at the end of the lecture, I will show some research projects where we use in-memory technology, where we use multi-core technology for storing and processing audit logs. It's a real intensive computation, a real problem which needs a lot of computational resources to be solved. See, it's not practical, I mentioned this already, due to the big amount of data to record every single piece. For example, each modification of a file. Also, each individual modification of a file, so it's a very, very tiny operation. Each modification of a file can have some consequences for the security of the system. But it's no useful and no practical to record all these events. So what is done is that redundant information should be filtered. So usually, for example, in manipulating a file, only the first access to a file is recorded in the audit logs, as well as the last access. So the intermediate accesses are not recorded. Although they could give hints for security-relevant actions or events, but it's too much information. So this is what I mean when I say redundant information should be filtered. So, for example, processing a file, only the first access and the last access is stored in the audit file. Although this could have the danger, that could provide the danger that a security-relevant action is not stored. Individual memory locations, individual hardware registers and instructions are also not audited due to complexity reasons. So there's a big discussion and very fine-tuned what kind of data are recorded in this audit logs, because almost all activities have an influence on the security of a system. Now the title of the lecture is Intrusion Detection System. So what is such an IDS, Intrusion Detection System? These are systems which are designed to detect an attack and to detect intrusions and break-ins. The intrusion detection, the IDS systems, they are based on mainly two different working principles. So there are two basic types of such intrusion detection system implementations. So one type is based on analyzing so-called anomalies. These are the anomaly-based intrusion detection, which detect anomalies in the behavior of the system. The advantage of this approach is I have a knowledge about the usual behavior of the system, and then I observe monitoring some unusual events. This helps me to conclude something is wrong, something has happened. Perhaps it's an attack, and it's not necessary to know what kind of attack it is. In this way, with the anomaly observation detecting systems, I can observe as well known as unknown attacks. What I need is a knowledge about what is the usual behavior, what are the parameters that characterize a usual behavior of a system. So these anomaly-based intrusion detections are based on training data and preset thresholds. There is a second basic type for intrusion detection system, and these are the so-called signature-based intrusion detections. Here the idea is that one investigates known attacks and tries to characterize such attacks by some significant patterns. And then the signature-based intrusion detection, they look for such pattern that give hints that there is an attack running. So signature-based intrusion detections are detecting known intrusions, which are based on signatures and patterns. The advantage here is I look for very special situations that are characterizing an attack. So for all known attacks, this is a very efficient approach. But I have no chance in this way, by such signature-based intrusion detection, to detect unknown attacks, because in the attack, in the signature database, there are no characteristics of the unknown attacks because they are unknown. Let's start a closer look to the what is an anomaly and to the anomaly-based intrusion detection system. In case a system or a network is attacked or intruded, the network's or the host's behavior is in some way different from the usual behavior. So one can see differences or mutations in various system parameters, such as the heavy CPU load, an unusual heavy CPU load, or strange activities on different input-output ports, or on the server or on the client. For example, one can recognize many failed login attempts if an attacker tries to intrude the system. One can realize a heavy network traffic. Bits are sent, received, bytes per net, per address port are very different from the usual behavior. Or others like system or network breakdowns, untypical packet size, or activities. If we have a closer look to such anomalies, then we can see two different classes of anomalies. The first one are so-called statistical anomalies. Here, the values deviate from the usual statistical values. And beside of the statistical anomalies, we can observe logical anomalies. Logical anomalies here, the behavior of hosts or of the whole network deviates from the usual behavior, and there is, for example, if there is a try to break into a system, many login attempts. So if there is in a very short time unusual number of such login attempts, this is a logical anomaly, and this gives an information to the intrusion detection to raise some action. How such anomalies can be detected? To detect such anomalies, the system has to do different steps. It has to do 3 preparing steps. First step is that training data are collected. The system needs to understand the usual behavior and to the usual characteristics. And of course, each computer is used in a different way. It depends from the user, it depends from the applications that run, it depends from the type of application. Also in a network, there are different usages. So I have to observe the usage of that system. I are responsible, and I want to install such an intrusion detection system based on anomaly detection. So collecting of training data is the first step. Observe several parameters of the host, observe several parameters of the network, which are characterizing the normal operation over a longer period. Second step is, from this data, from this trainer data, one needs to recover so-called baselines. So-called baselines, basic characteristics of a variety of parameters that characterize the usual work. And then in the third step, one has, on the basis of this found baselines, one has to define thresholds. Thresholds, if the difference between the baseline and the threshold, if there is in the behavior in a certain parameter, the larger difference that oversize the threshold, then an alert is raised. Because I cannot work with a baseline, because in the everyday use, of course, there are differences to the baseline in the characters. And I have, by the third step, to characterize up to which deviation it's considered to be a normal difference, and when it starts to be considered as an abnormal difference. On the basis of such baselines, an intrusion detection system can be installed and configured, which is based on detecting such anomalies. The system then, the intrusion detection system, permanently observes all characteristic parameters and then compares these parameters against the predefined thresholds. Statistical determined, or whether this is manually configured, whether this is a self-learning system that adapts these thresholds to changing usage of a system. This is the same. This is not the system compares the characteristic, the characters, the parameters against this thresholds. And then, if there is a deviation, then and for each such attack, profile is defined on the basis of this deviation of the baseline. Then the intrusion detection system is able to detect such anomalies. So if the system detects such deviations, it sends alerts. The system automatically sends an alert to the network operator or to the system's administrator. What are the advantages of this system, this detection, this intrusion detection system that are based on anomaly detection? The advantage is these systems are able to detect as well known as well as unknown attacks. Because here we do not work with a characteristic of a certain attack. Here we work with considering what is the characteristic of the usual behavior of the system, and then observe whether there is a deviation from the usual behavior. But what are the problems with this approach? Problem with this approach is to be able to detect such anomalies. The intrusion detection system has to process a huge amount of data. And it has to be done in a short time, best in real time. And what is a huge amount of data? So typically, such intrusion detection system need to be able to analyze 3 to 35 megabytes data per user per 8 hours. So that's a big amount, because this has to be done aside of the usual work the system is designed for. Some particular usage of a host or a network may look like attacks, but are no intrusions. So in this case, such intrusion detection system based on anomaly detection raise an alarm, a false positive alarm. What are such unusual detection? For example, if in a company there is a social event, and this is only a few times a year, so it's not considered as a usual behavior. There are some extra activities with invention or people from outside that have to register us. So this is different than the usual behavior. It is an event of the company. It's not an attack, but the system considered it as an attack and gives an alarm. The intrusion detection system should adjust, therefore, the baselines and the thresholds. And here are different possibilities. A good approach is so-called self-learning mechanisms, so that the baseline which characterizes the usual work is adapted also to changes in the work. But of course, in this security relevant area, we have seen already that things that are provided, that are designed to provide support, can be misused also by the attacker. So what attacker can use is that they adapt the system on their attack methods by misusing the self-learning mechanisms and starting with some activities in a low extent that are part of their attack, and then increasing this amount of action over a longer time period. And then automatically, due to the self-learning mechanisms, the characteristic behavior of the system is considered also that this attack, from the attacker, these activities are considered as a usual behavior. So here one needs to be careful, but in any case, one needs to think that this training data, this baseline and the thresholds need to be adapted from time to time. Now let's have a look to signature-based attack, signature-based intrusion detection systems. Here the idea is that certain event patterns are used to characterize an attack or an intrusion. Each event in a communication process belongs to a so-called event class. So for example, an IP event is a general IP datagram, or a TCP event is a TCP packet, or TCP SYN is the start of establishing a TCP connection, or TCP SYN plus acknowledge is acknowledgement of establishing a TCP connection. So every event can be is part of an event class. Now, one needs to characterize such events class by event patterns. These event patterns are formed from logical relevant classes. And the logical characteristics of attacks are collected, are stored in a so-called signature library. In the signature library, the characteristics, characteristic event patterns of attack activities are stored, and this also forms the basis for this intrusion detection system, which compares the event patterns that happen with the event patterns that are stored in the signature library. There are stored attack patterns, intrusion patterns, and there are stored other relevant parameters pointing to an attack which are determined statistically or configured manually. Intrusion detection system compares now and evaluates sequences of events during the daily work. So the daily work is, there are some characteristic patterns, and these characteristic patterns are compared by the intrusion detection system to the patterns of the attacks and intrusions that are stored in the signature library. And if there is a deviation, if an event description matches an entry in this signature database, then an alert is raised. What is the advantage of this approach, of this signature-based intrusion detection system? This type of intrusion detection system work on a very high quality signature database, working with a high quality signature database, provide high accuracy. If the database has stored all characteristics of all attack intrusion patterns, then there is a very good chance to detect such attacks. But you see, the quality depends from this signature database. Exactly, that's the problem. And the database can only store event characteristics of known attacks. Unknown attacks need to be analyzed. Unknown attacks, before they can be detected by such signature-based intrusion detection system, need to be it's necessary to find the characteristic pattern of this new attack. So new attacks cannot be detected. That means that this attack signature library needs to be updated as soon as a new attack is discovered. If users of such intrusion detection systems, of such signature-based intrusion detection system, do not update their signature library, then the intrusion detection is not be able to detect attacks. So this is a problem with the signature-based intrusion detection system. They can discover attacks with very high precision when the underlying attack library is up to date. They have a problem to recover unknown systems. To give an example of such signature-based intrusion detection system, we can have a look to antivirus software. So antivirus software are a famous example of such signature-based intrusion detection systems. Here, the vendors of these systems provide frequently signature updates. So I remember in the early days, the user has to update this database by himself. Meanwhile, this update is done automatically so that the user is not necessary to care about, because I remember former times when the user has to perform the update, and many users were happy, were thinking when they have bought the system, then they have done enough. So they didn't care about updating the system. Then it was quite useless. The question is how the vendors get this signature of the attacks, in this case of the viruses. So all these antivirus software vendors, they run libraries by professional malware analysts that try to find the characteristics patterns of the various viruses. So the generation is based on samples, for example, on malicious software that's newly detected, but also on exchanging data between the vendors. Where the data can be found, data can be found by so-called darknets. Here the first occurrence of such virus, of such malware. Such darknets are networks without domain name service entries that are used to collect worms and viruses. They can be, the information can come from users that are detecting a virus on their system, or they have an exchange of information between the vendors. So they provide samples of potential malware and signature and of analyzed signature, all to hold the antivirus software database, signature database, up to date. There are also used heuristics to detect malicious behavior. So that's because of their different strengths and weaknesses. The approaches for the design of such systems are used. Not only signature-based are used, but also anomaly things are used. Now let's have a look how such intrusion detection systems are implemented or can be implemented. Also here we can see two different basic objects for such intrusion detection systems. The one is to detect attacks and intrusions in a network. And systems that are designed to detect intrusions and attacks inside the networks are the so-called network-based intrusion detection systems, the NIDSs. Here, the goal of the system is to search for patterns or to search for anomalies in the network traffic. And this can be easily done by the promiscuous interface where all the traffic is observed and analyzed. The aim is to protect the whole network. Beside of the network-based intrusion systems, we have the host-based intrusion detection systems, the HIDS. And here the goal is to search for attacks and intrusion patterns and anomalies on a host system. On a host system, there are log files, there are network traffic characteristics of the host. Here, not the promiscuous mode is used, but here only the network traffic of the host is analyzed. So these are the two approaches to implement an intrusion detection system. Let's have a closer look to the network-based intrusion detection system. Such network-based intrusion detection use all raw packets, network packets, as the data source for their analysis. So typically, this data are collected by a network adapter in the promiscuous code, in the promiscuous mode. In the promiscuous mode, listen to all activities inside the network and analyzes all the network traffic in real time. Then, by means of a first level filter, it is determined which traffic will be discarded because it's considered as dangerous and which traffic is allowed to pass to an attack recognition model. So for the analysis, there is an attack recognition model, and this adapter, this network adapter, decides whether there looks something dangerous and needs to be analyzed, or whether it is considered as a usual traffic and can be discarded. Here, one needs to be, the system needs to be careful because, of course, the traffic may be spoofed. The attack recognition module of this network-based intrusion detection systems is based on detecting attacks by means of patterns, by means of frequencies, by means of anomalies. And if system it detects an attack, then a response module starts an action, such as notify the network administrator, raise an alert, or others. So this network-based intrusion detection system work with a network adapter, work with an attack recognition module, and needs to work with an attack recognition and attack response, where this an attack response module. What are the strengths of such network-based intrusion detection systems? Strengths are it's relatively cheap. It's low cost since such network-based intrusion detection system can be placed in a strategic position in the network and can observe and watch for many systems connected to the network within a limited space. Packets can be easily analyzed. One network-based intrusion detection can analyze the network headers, the packet headers, but can also analyze the content of the packets. They avoid evidence removal by using real-time network traffic for attack detection. This is an advantage of this network-based intrusion system. And they can realize and respond in real time to an attack. Such network-based intrusion detections are independent from an operating system of a host system. They observe the network traffic and conclude in whether there is an attack on observing the network traffic. If we look on the other side to the host-based intrusion detection system, then here we have the situation that such an intrusion detection system that's placed in a host can work with various audit logs for a sophisticated and automated real-time detection and response. Such host-based intrusion detection systems use software that continuously monitors specific logs of the host systems, such as security logs for Windows or security logs for Unix, you know this, or other sensors inside a host or connected to an application running on the host. And as soon as these files are changing, the host-based information system compares this state with the current configuration of the security policy, and eventually it responds by raising an alarm. Some of these host-based intrusion detection systems monitor log activities in real time. That's the so-called streaming mode. One, check files, the so-called file integrity checkers. This is done periodically. So-called bash mode. Streaming mode is real time. Bash mode is periodical from time to time. And some of this host-based intrusion detection system monitor port activities and alert if specific ports are opened or if there is a try to access this. If we look and consider the strengths of this host-based intrusion detection systems, then we can see there is an attack verification possible. There are specific activities of the system and of the application that can quickly monitor and can help to decide is there an attack or not. There is also possible to detect encrypted and switched environments. If we go back to the network-based information systems, they do not understand under encrypted data. They can analyze the head. The head, a big part of the head at least, cannot be encrypted. Otherwise, the internet working would not work. But the content could be encrypted or some information. Here on the host-based system, the encryption mechanisms are known and also are applied. The system decrypts the information and then it can be analyzed. It is possible to monitor key components of the host, and it's possible at least nearly real-time detection and response, and one does not need additional hardware, because such host-based intrusion systems are software systems that can be placed in the system they have to observe. Is it possible to work only with network-based system, intrusion detection system, or is it possible only to use host-based intrusion detection system? And I will argue we need both. We need both, so the typical competitiveness of the network-based intrusion detection and a host-based intrusion detection system. So here are some examples of attacks. We have discussed these attacks in former lectures. And some of the attacks can only be analyzed and can only be detected by network-based or only be detected by host-based. So for example, if here's the intruder and here is the victim, then thin flood attacks. It's easy for a network-based intrusion detection system to detect this, but not possible for a host-based system. Or land smooth teardrop attacks, nuke attacks. These are attacks that can be relatively easily detected by network-based intrusion detections, but not by host-based intrusion detection. If we look on the other side, other types of attacks, then other types can merely detected by a host-based intrusion detection system. For example, if it has to do something with an encrypted network traffic, rootkit detection, work up to keyboard attacks and others, this type of attacks can be easily detected by host-based and not by network-based. So you see, in a concept for an intrusion detection system, we need both approaches, the network-based approach and the host-based approach. As well, network-based as host-based intrusion detection systems solution have their unique strengths and they have their unique weaknesses. So the idea is to combine this two type of intrusion detection approaches. So next generation must include the integrated implementation, which combines both types of intrusion detection system. To run such an intrusion detection system, a so-called intrusion detection system management system is used. And these systems, these management systems that combine and integrate as well network-based intrusion detection as well as host-based intrusion detection system often are called distributed intrusion detection system. Then there are components in the network, there are components on the host, and there is a management system, an intrusion system management system that combines, integrates, and merges this data from the host-based as well as from the network-based system. So here is another overview how it makes sense and why it's important to combine this network-based and the host-based intrusion detection system. We have our intruders, we have our network size, and here are different activities, telnet to a system to watch whether it's an attack or what is this an usual telnet service request. This can be detected by a network intrusion detection system. Intruders, super users to root or turns off logging. This may be detected by host-based intrusion detection system. Port scan, HTTP, CGI, bin attacks, we have discussed this. They can be detected, easily be detected by network-based intrusion detection system. Change of web pages, this is possible to detect by host-based intrusion detection system. Here is another approach for implementing an intrusion detection system, and it's so-called virtual machine-based intrusion detection system. Such a VM-based intrusion detection system uses, the name says it, uses virtual machine monitor functionality to monitor hosts such as memory introspection, so runtime analysis of the VM's RAM to find malicious behavior, the hard disk drive introspection, so the analysis of VMware's virtual machines hard disk to find, for example, hidden files or malicious programs. So virtualization of target hosts helps to separate the intrusion detection system from the target host. So then it's hard to attack. In a traditional way, if you have a host and you have placed the attack, the intrusion detection system on the host, so the attacker wants to, in an attack, in the first way, tries to attack the intrusion detection system to switch it off or to prevent that this can raise alert. Here, if you work in the virtualization to separate the intrusion detection system from the targeters, it becomes impossible, at least hard to attack. And of course, this is a security feature provided by the virtualization mechanisms. Also, the virtualization of the intrusion detection system, then the compromised intrusion detection system is separated from the virtual machine management system. And then in this way, it's easy to be recovered and its alert can be raised. A short view how one should react, how intrusion detection system react if they are able to detect an attack or intrusion. I mentioned in several points they raise alert. What does it mean? According to the potential attack threats of an attack, an intrusion detection system is able to aviate different alert mechanisms. So, for example, on a central console, all messages of the decentralized agents, for example, the network intrusion-based components and the host-based intrusion component, are collected, are merged, are summarized. I already introduced this is an intrusion detection system management system, sometimes also called security, information, and event management. Security, information, and event management, so-called CM systems, if you look to literature. And the data, it's important, need to be recorded. The data that give a hint that there is an alert need to be recorded in log file or in database, so that's possible later on to analyze this data. Raising an alarm also means to send an email with an information about alerts to the administrator, or there are different levels of alert. It could also be to give the administrator a phone call or to send him an SMS to give awareness, to create awareness by the system and network administrators. But intrusion detection system can also start some automatic routine in case of alert. So they have to record, there is a recording tool which stores all packets from the attacker. So this is for later detection and analysis of the attack. There are more methods. Let's have a look to the reactions when an attack is detected. The one is alert is raised to the administrator, to others, data are stored. What are prevention techniques? I mentioned that in case of alerts, the intrusion detection system can start some automatic routine. For example, the intrusion detection system can interrupt the network connections to an attacker by means of an RST packet, at least in case when a TCP connection is established. The intrusion detection system can automatically reconfigure the firewall or the firewalls. Intrusion detection system can automatically isolate attacker from the network. Or intrusion detection with a capability to prevent attacks. Intrusion detection that that are able to perform such automatic routines, they often are called intrusion prevention systems, IPS. not only detection system, but also prevention system. Or another name is intrusion detection and prevention system. You have to go to literature to see more. We have only short time to give a survey about the activities in this field. But attention, all these prevention techniques can also be misused by the attacker. For example, by running a denial of service attacks. I mentioned this already when we discussed concrete attacks, that one goal of the attacker could be to bring such an intrusion detection system to let it break down, or let it raise an alert and perform such activities like cutting connections. Then, of course, if an attacker has not the goal to break in, but the attacker wants to perform a denial of service attack, this is a way of performing such a denial of service attack to force the system to do something that afterward it's no more able to perform in the correct way. Here is some ideas and some activities for intrusion responses. In most cases, it's difficult to find the attacker and to find the identity of the attacker. And the reason we know all. The reason is that the attacker mostly work with multiple distributed computers that are not well connected. Often attacks are run by means of botnets. And botnets, the botnet clients, that are computers that are connected to the internet and that are not well connected, for example, computers at homes or sometimes in university tool rooms or others. They use different call-in connections with different IP addresses. Also, this makes it difficult to identify an attacker. The attacker work, and that's easy, with spoofed IP addresses. With spoofed IP addresses or with spoofed MAC addresses. Also, this makes it very difficult to find the identity of an attacker. Sometimes it is possible to identify an attack station. But have in mind, in most cases, this attack station is not the computer of the attacker. So, a typical example is that of a botnet. How to find the owner of an attacking IP address? There exist services like WHOIS or DNS lookup. So one can identify, and that's the reason that intrusion detection have to record in case of attacks all the data. So you can identify the attack station, for example, using this. And you can also following back the route to the attacking station by systems, by services like traceroute with the appropriate IP address. But in any case, you should not do own activities. In cases of very serious attacks, there are national, there are enterprise, there are national, also there are international emergency response teams, so-called CERTs. They can be notified about the attack, and they can often provide information how to repair or secure, and they have means also to find involved attackers. But in any case, do not start any attack against the detected attacking station. This is a reflex, an often automatic reflex of people that are a little bit involved in the IT security area and that have abilities. you are not allowed to do this. There are several reasons. The first reason is you would probably hit innocent people, because the attacker is not using the station you identify as an attack station. This is a bot client or others. More important is this, why you should not do a counterattack is, attacking is criminal. And it's not an excuse to do some criminal act, to say there was an attack against me done before. Attacks are criminal attacks, and nobody is, you are not authorized to do it. There are teams, for example, in case of cyber war, that are authorized to do something, but you as a victim of an attack should not try to perform a counterattack. You should inform the administrators, you should inform the various threats, but you should not do own activities. Let's have a look on the more advanced situation. This was the traditional approach, and I mentioned that we have new techniques with the virtualization, and particularly with the combination of network and host-based system. Here I want to give a short insight into some research activities, and the keyword, the headline for this is event correlation. The traditional intrusion detection systems just recognize single attacks. So usually only one-step attack. But from our discussion in our lecture, we have learned that big attacks are a sequence of several smaller attacks. First, to find out some information in victim systems, then to prepare intrusion, then to perform intrusion, then to attack other things. So a real attack event is a sequence of several such single attempts. So what is necessary and what's considered to be the necessary is to find out whether single attack steps correlate to a complex attack scenario. So for example, a remote port scan on victim system. This can be recognized by a network-based information system, intrusion detection system. Remote root exploit on victim system. The local installation of backdoor software that's recognized by the host-based intrusion system. Further attacks on the network from the network. They are sometimes recognized by the single systems. Sometimes they are recognized by the network intrusion detection system. And now it's important to combine this information to analyze whether there is a complex attack scenario which consists of the single steps that may be detected in the several points of the system. And mean for correlating, for finding out, a mean for finding out whether single attacks correlate to a complex attack scenario are so-called attack graphs. Attack graphs can be used to model such complex attack scenarios and to provide a mean for detailed analysis. This alert correlation, this finding out whether single steps of an attack form a complex attack scenario. This alert correlation helps filter and reorganize that only the interesting are the serious attack information, that only the interesting event information is collected, which is helpful to help the security operator to identify complex attack scenarios in a short time. You understand? the traditional way is to identify single attack activities, but a real attack consists of a scenario of many such single attack steps. And the modern, or the idea of modern intrusion detection system that have to be designed in future is that such system should be able to recognize such complex attack scenarios, and this can be done by this event correlation. Such an event correlation framework needs several components. So it starts with a normalization of the various events, security event, to unify the alert. It needs to normalize the format. It is a classification needed, a time, and so on. And then, next step, a clustering, a so-called aggregation is necessary to aggregate similar results. Then one has to find out whether these similar results form a complex attack scenario, and this is done by means of correlation algorithms. The correlation of a set of alerts to get more information about the attack. Then it's a problem that false alerts were given, even false positive or false positive attacks. So in this event correlation framework, also a component is needed that removes alerts that are false positives. The reason with the false positives, the false alarm to the system administrator in case there is no event. The problem here is that after getting a couple of such false alerts, the system administrator becomes lazy and will not respond if he or she gets next response, next alert. And the next alert, that could be a true alert. So this false alert reduction is an important step. And finally, the attack strategy analysis. To find out what is the goal of this attack events that correlate to such a complex attack scenario. What is the goal of the attacker? And then to be able, detecting the goal, to activate some prevention methods. And finally, the prioritization of the alerts is needed to find out, to check how dangerous a certain attack scenario is. Let's have a look to this step of the correlation algorithms. This is interesting. The correlation algorithms can be categorized due to the methods they are using to correlate such alert events to a complex alert scenario. They can work rule-based. So rule-based correlation, that the rules could be customized for many purposes. For example, events of an attack with the same source, recognizable by a common IP address and others. Then statistical correlation. The discovery, the detection that is based on historical data and the comparison with historic data. These correlation algorithms can be based on temporal correlation. So for example, correlation of information about one or several similar events from different sources. Or they may be scenario-based. Here, I mentioned already the tool, the attack graph, that is based by our security lab, our security analytics lab in HPI from our security team, which we design and propose to work, that it's based on this attack graph correlation. So here we have the sequence of events, and from the sequence of events, such attack graphs are constructed. And the attack graphs, they model a complex attack scenario consisting of several such single attack events. So our HPI Security Analytics Lab, Fung Sheng and Ami Asodi, David Jäger, they are doing their research work in this field, their PhD or their postdoc habilitation work. Here the idea is that we try to provide an advanced implementation of such an security, information and event management system, such an CM. I introduced this already. And the idea is that this system should be able to gather and to correlate a huge amount of data of multi-types, heterogeneous sources like log files from the operating system, scanning reports, intrusion detection, system alerts, virus, firewall warnings, monitor logs, and others. The problem here is the complexity. So we try to come with a system that is able to analyze a much bigger amount of data than this was done before. And of course, we have very strong techniques. We have this in-memory technology. We have multi-core in our future SOC lab. We have all this most advanced computing power at hand. And we try to provide it, we try to use it for the purpose to find out whether a complex network of systems in the network system is attacked. The SAL, the Security Analytics Labs, HPSL, runs in two modes. The bash mode. Bash mode is using the state of fixed data and analysis not in real time, and the streaming mode that is inspecting continuously incoming events. I mentioned already we apply in-memory and multi-core technology to speed up. The former intrusion detection system give next day information that yesterday something happened. And of course, that is not satisfying. So what we want to have is to see best in real time or almost in real time that there is an attack running. And here you can see our security lab, security analytics lab database. So we will announce this soon that we collect from all the sources, from all different sources that are available, information about vulnerabilities and transfer this in a machine readable form, so that systems automatically can get information about weaknesses and can analyze, when they're analyzing their system, whether such a known weakness is misused by an attacker. The lab supports many known correlation algorithms that we know from literature. It includes a scenario-based correlation. So some of you also remember Sebastian Roschke. He did his PhD in this field. And we use the approach of this, I think the most advanced approach of this attack-based correlation. We support the different standards that are in place for such describing of weakness and of system and software. There is on one side the EDM-EF standard, the intrusion detection message exchange format for IDS alerts. There is a CEE standard, the common event expression for logs and other events. And there is a national vulnerability database, the NVD, where all the known event activities are recorded. And I mentioned already, soon we will make it public and will make it accessible from the internet our HPI VDB, our HPI vulnerability database soon. For more readings and discussions, here you can see information on our website, but you can also discuss during the exercises and the seminars with that guys that are involved here in this research. What are limitations of intrusion detection systems? Due to the complexity of the task, there is obviously no guarantee about the results of EDS. So we have the problem of false positives. So a false alarm is raised on harmless user behavior, a little bit different than the usual behavior, and the system classifies it as an alert. The false positives are no dangerous in the sense that they cause any damage, but they make the user confused against the possible network attacks. Here an example: if many regular users try to establish a connection to a web server because there is a new information available, then this could be interpreted by such an intrusion detection system as a SYN flooding. The measure is the change if such false alerts can be observed to a bigger amount. One needs to change the configuration of the intrusion detection system, but one has to do this careful, not to change the baseline in a way that the real alerts are no more detected. There is a problem of false negatives. False negatives means there is an attack, but no alert is raised, and this is problematic. Because here there could be the attack could be cause damage, and the system does not realize this. What are the reasons for this behavior? The possible reasons are that an intrusion detection system does not detect an intrusion, is that the signature database is not up to date, that the software or the design error in the intrusion detection system, that the statistical thresholds are seen too high in order to prevent alarms, or that the intrusion detection system itself is a victim of a denial of service attack, so that it's meanwhile under the control of the attacker. Another reason for the false negatives is that the profiles do not correctly describe the normal work of the system, and the statistic description of the behavior of the profile, even if you have installed such a self-learning mechanism, was adapted smoothly over time by the attacker to prevent that when he performs the real attack, that the system calls an alert. Of course, the goal is to minimize the risk of false negatives, and this can be done or needs to be done by adopt the appropriately intrusion detection strategy and solutions, the careful appropriate deployment and configure of an intrusion detection system. This concerns particularly the description of the usual behavior. One needs to update the intrusion detection software and the hardware on a regular basis, and one has strictly limit the number of persons who know the concrete intrusion detection deployment and configurations. So the more people this know, the more dangerous it is. Then there is a change default ports for administration of intrusion detection system. It's a possibility to change the false negatives. I want to conclude the lecture with a few remarks about how we can evaluate, how we can measure the work of an intrusion detection system, how we can measure the work of intrusion detection systems and sensors. You know, in a scientific work, the goal is to find scenarios, to find way to objectively measure things. And from this measurement, then one can make some conclusions. To perform these measurements, one needs some notions. So here, when I define some things, so I is the parameter that an incident happened, and not I is the incident does not happen. A is that an alert was sent, and not A is no alert was sent. And now we can compute probabilities. So the false positive rate, FP, that's a probability that an alert was generated in case of no attack. This can be computed as a probability that the alert was raised while no incident happened. The false negative rate, the FN rate, this is a probability that no alert was generated in case of an incident was happen. That is the probability of not alert of the not alert event under the restriction that an alert was happen. Then we have the true positive rate, and this is the probability of detecting an attack. And of course, you can compute this. The true probability is 1 minus the probability of a false negative. So 1 minus the false negative rate, and this is that an alert was raised under the condition that an accident happened. There are more parameters to characterize and compute the work of an intrusion detection system. So this is a so-called ROC curve, the receiver operating characteristics curve. This describes the relation between the true positives rate, TP, and the false positives rate. The ROC curve can be calculated by use fixed data, a set of traffic for the experiment, that is a known attack, and then modify the sensitivity of the intrusion detection system, for example, by enabling or by disenabling certain signatures or increasing or lowering the thresholds. So this is exactly the idea, to get measures to perform actions and to know what action need to be performed and in what amount, in what changes are useful. The measure of the false positive rate and the true positive rate is done and described for this ROC curve. And then at the end, one can draw the ROC curve. Here is an example of such an intrusion detection system. And we have an intrusion detection system A, and we have an intrusion detection system B, and we compare the efficiency and the performance of these two systems. Here is the positive rate, TP, on this scale, and here is the false positive scale. And you see the ratio between the true positive ray and the false positive ray that describes the power of performance, power and performance of intrusion detection system. And here the relation is much higher. There is a much higher true performance rate, true positive rate compared to the false positive rate. This is also only a short view on such things. On the basis of such measurements, then you can tune the intrusion detection system, and then you can see can really objectively evaluate the efficiency and the performance of such intrusion detection system. So you see, it's a large area. One could have many more lectures about this. We have only limited time, so we comprised it in one lecture. But I encourage you for further reading. I encourage you to discuss with our researchers to get more insights into the actual work. Perhaps you also like to become a Hiwi or a master worker or whatever. I hope it was interesting for you. Thank you for your attention.